We're diving straight into a cosmic mystery today. A real whodunit, except this one is set at the very beginning of time. And the victims? Well, there are nice, neat theories about how the universe is supposed to work. The culprits are these giant, supermassive black holes that are showing up way, way too early in the cosmic timeline, far bigger and far sooner than they have any right to be.
And look, this isn't just some small puzzle scientists are kicking around. As this quote makes pretty clear, these early black holes they don't fit. They can't be explained by our current models. It's the kind of discovery that sends cosmologists scrambling back to their whiteboards. And honestly, that's what makes this whole thing so exciting.
So it all boils down to this one absolutely maddening question. You see, if a black hole is born from a star and grows by eating matter, there's a kind of cosmic speed limit to how fast it can bulk up. But these ancient monsters, they seem to have completely shattered that speed limit, and astronomers are in a flat-out race to figure out how they did it.
Our investigation really begins with the high-tech detective that blew this case wide open, the James Webb Space Telescope. By peering deeper into space, and therefore further back in time than we ever have before, it's uncovered a crime scene that is baffling just about everyone.
The specific era Webb is looking at is called the cosmic dawn. I mean, this is the universe in its absolute infancy. To put that into perspective for you, if the entire history of the universe were a 24-hour day, this would be happening in like the very first minute. It's a time when everything was just getting started, which is precisely why finding these fully formed monsters here is just so shocking.
Yeah, the problem is this. The galaxies from this period were supposed to be tiny, right? And the black holes inside them, even smaller. But that is not what Webb is finding. Its observations are in direct conflict with our established theories, and it's forcing us to ask, have we misunderstood something really fundamental about how the universe grew up?
So what's the actual evidence? Well, the primary clues are these things that astronomers have nicknamed little red dots, or LRDs for short. And these faint little smudges, spotted by Webb all across the ancient cosmos, are where our primary suspects are hiding out.
So what are these little red dots exactly? Well, they're basically compact baby galaxies that look red to us because they're wrapped in these thick clouds of dust. And hidden deep inside that dust are these incredibly active, feeding black holes that are growing at an absolutely ferocious rate.
100 million. That is the mass, in suns, of a black hole they found in one of these little red dots. We're seeing it as it was just 570 million years after the Big Bang. A black hole of this size simply shouldn't exist yet. It's kind of like finding a fully built skyscraper in a village that was only founded yesterday. It just makes no sense.
Okay, so how in the world do we explain it? The investigation has two main lines of inquiry, two primary suspects for how you could possibly form a giant black hole this fast. They're called the light seed and heavy seed models.
All right, so the light seed idea is the traditional one. A black hole starts small, maybe 100 times the mass of the sun, after a giant star dies. But to get to 100 million solar masses that quickly, it would have to be eating nonstop at a rate that's pretty much impossible. The heavy seed model, though, it offers a way around that. What if the black hole got a massive head start? What if it was born already tens of thousands of times the mass of our sun?
So here's how that direct collapse idea would work. You get a huge, pristine cloud of gas in the early universe, and it gets so dense that it just collapses under its own weight. But, and this is the key part, instead of breaking up into a bunch of stars, the entire cloud collapses all at once, straight into a massive black hole seed. It completely skips the whole becoming a star phase, giving it the huge head start it needs to become a monster.
But, you know, the heavy seed model isn't the only suspect in town. The sheer scale of what Webb is finding has opened the door to some even more exotic, even wilder possibilities. So, yeah, the plot definitely thickens. One of these ideas, the POP 3.1 model, is a really cool twist on the heavy seed theory. It suggests that before you even get the black hole, you first form a supermassive star, a brief, brilliant object thousands of times the mass of our sun, which then collapses. And what's cool is, not only would this create a heavy seed, but its intense radiation could also help solve another huge cosmic puzzle, how the early universe became transparent to light.
Okay, get ready because this next one is a real head-scratcher. It's called Coherence-Driven collapse. Imagine a speaker playing music in a room. The music is its mass. This theory suggests the room itself could change shape to amplify that music, making it seem way louder without actually turning up the volume.
In the same way, as the spacetime around a black hole changes its state, its gravitational pull gets massively amplified, so it gains influence without actually having to eat more stuff. Wild, right?
And what if there was an accomplice? Some theories are proposing that fuzzy dark matter could be the partner in crime here. See, this type of dark matter could form these superdense cores called solitons. You can think of these solitons as gravitational boosters, creating a much deeper gravity well that just funnels gas into the baby black hole way more efficiently. So in this story, dark matter is the secret ingredient that lets them grow so fast.
So why does any of this matter? I mean, why are we so obsessed with these early, oversized black holes? Well, it's because they aren't just a curiosity. They are tied to some of the deepest, most fundamental questions we have about the entire cosmos. And cracking this case could honestly rewrite everything we thought we knew.
You know, solving this mystery is going to tell us how the very first galaxies were born and how they grew up alongside their black holes. And some of these new theories, they could actually offer unexpected solutions to other huge problems in physics, like the famous Hubble tension. That's this major disagreement over how fast the universe is expanding. A new model for black hole growth could change our understanding of the early universe just enough to make that tension go away. The stakes here are just incredibly high.
And that really leaves us right here, standing at the very edge of our understanding. Are these ancient monsters just the missing piece of the puzzle? The key that finally makes all our theories click into place? Or are they something else entirely? Are they the first definitive proof that our fundamental rules for how the universe works are just plain wrong, and that we have to go back and start all over? The investigation continues.